Welcome to Pumping Python. My name is Jacob Itegboje, and this is the truth table tests. Time to write some code. I'll open the terminal, then close test truth table.py. I want to write the functions that make the test pass without looking at them. Select everything in truth table.py, hit delete. The terminal shows 20 failures. I'm going to pay attention to the last message in each case. Attribute error. Module source truth underscore table has no attribute tautology. I will add the name to the file. The terminal shows name error. Name tautology is not defined. Equal sign none to define it. The terminal shows type error. Non-type object is not callable. DEF tautology parentheses colon return, remove the equal sign none. The terminal shows type error. Tautology takes 0 positional arguments, but 2 were given. In the parentheses, I'll put x, y to name my inputs. Assertion error. None is not true. Change none to true in the return statement. The terminal shows no attribute project second. DEF project underscore second parentheses x, y colon return true. The terminal shows assertion error. True is not false. Change true to false. The terminal shows assertion error. False is not true. I'm not going to keep playing that game, so I'll return x, y to see the difference between the inputs and the expected output. The terminal shows assertion error. True, false is not false. Well, y is false, so I'll remove x. No attribute project first. DEF project underscore first parentheses x, y colon return x, y. Assertion error. False, true is not false. X is false, I'll remove y. No attribute negate second. DEF negate underscore second parentheses x, y colon return x, y. Assertion error. True, true is not false. Since both of these are true in this case, I will use an if statement. If parentheses x, y is equal to true, true colon return false. Assertion error. False, true is not false. If parentheses x, y is equal to parentheses false, true colon return false. No attribute negate first. DEF negate underscore first parentheses x, y colon return x, y. Assertion error. True, true is not false. If parentheses x, y is equal to parentheses true, true colon return false. True, false is not false. If x, y is equal to parentheses true, false colon return false. No attribute material non-implication. DEF material underscore non underscore implication parentheses x, y colon return x, y. Assertion error. True, true is not false. If x, y is equal to true, true, colon, return false. False, true is not false. If x, y is equal to false, true, colon, return false. False, false is not false. If x, y is equal to false, false, colon, return false. No attribute material implication. DEF material underscore implication parentheses x, y, colon, return x, y. True, false is not false. If x, y is equal to true, false, colon, return false. No attribute logical nor. DEF logical underscore nor parentheses x, y, colon, return x, y. True, true is not false. If x, y is equal to true, true, colon, return false. True, false is not false. If x, y is equal to true, false, colon, return false. False, true is not false. If x, y is equal to false, true, colon, return false. No attribute logical NAND. DEF logical underscore NAND parentheses x, y, colon, return x, y. True, true is not false. If x, y is equal to true, true, colon, return false. No attribute logical equality. DEF logical underscore equality parentheses x, y, colon, return x, y. Assertion error. True, false is not false. If x, y is equal to true, false, colon, return false. False, true is not false. If x, y is equal to false, true, colon, return false. No attribute logical disjunction. DEF logical underscore disjunction parentheses x, y, colon, return x, y. False, false is not false. If x, y is equal to false, false, colon, return false. No attribute logical conjunction. DEF logical underscore conjunction parentheses x, y, colon, return x, y. True comma false is not false. If x comma y is equal to true comma false, colon, return false. False comma true is not false. If x comma y is equal to false comma true, colon, return false. False comma false is not false. If x comma y is equal to false comma false, colon, return false. No attribute exclusive disjunction. DEF exclusive underscore disjunction parentheses x comma y colon return x comma y. Assertion error. True comma true is not false. If x comma y is equal to true comma true colon return false. False comma false is not false. If x comma y is equal to false comma false colon return false. No attribute converse non-implication. DEF converse underscore non underscore implication parentheses x comma y colon return x comma y. True comma true is not false. If x comma y is equal to true comma true colon return false. True comma false is not false. If x comma y is equal to true comma false colon return false. False comma false is not false. If x comma y is equal to false comma false colon return false. No attribute converse implication. DEF converse underscore implication parentheses x comma y colon return x comma y. False comma true is not false. If x comma y is equal to false comma true colon return false. No attribute contradiction. DEF contradiction parentheses x comma y colon return x comma y. Assertion error. True comma true is not false. If x comma y is equal to true comma true colon return false. True comma false is not false. If x comma y is equal to true comma false colon return false. False comma true is not false. If x comma y is equal to false comma true colon return false. False comma false is not false. If x comma y is equal to false comma false colon return false. No attribute logical negation. Did you mean logical conjunction? DEF, logical underscore negation, parentheses x comma y, colon, return x comma y. The terminal shows type error. Logical negation missing one required positional argument y. I'm going to remove it from the function. And I get assertion error, true is not false. Since x is true, I will return not x. No attribute logical identity. DEF logical underscore identity, parentheses x, colon, return not x. The terminal shows assertion error. False is not true. Remove the not. No attribute logical true. DEF logical underscore true, parentheses x, colon, return x. The terminal shows type error. Logical true missing one required positional argument x. I will remove it from the function and return none. The terminal shows assertion error. None is not true. Change none to true in the return statement. The terminal shows no attribute logical false. DEF logical underscore false, parentheses colon, return false to match the name. And all the tests are passing. The terminal shows green. I can refactor now. This is already pretty simple. So is this and this one as well as this. Okay, contradiction returns false in 4 cases. But with 2 inputs, there are only 4 cases. So this is just returning false all the time. Return false. The test is still green. I'll remove the other lines. Converse implication returns false in only one case. It returns 3 in the others. I can represent that as return parentheses x comma y is not equal to parentheses false comma true. Still green. Remove the other statement. Converse non-implication returns false in 3 cases. It returns true in only one case. So that would be return x comma y is equal to false comma true. Still green. I'll remove the other lines. Exclusive disjunction has 2 cases where it returns false. I can put these 2 if statements together as one. If parentheses x comma y is equal to parentheses true comma true, or parentheses x comma y is equal to parentheses false comma false, colon, return false. The test is still green. I'll remove the other 2 if statements. Then return the negation of this if statement. Return parentheses x comma y is not equal to true comma true, and x comma y is not equal to false comma false. The test is still green. Remove the other lines. Logical conjunction only has one case where it returns true. Return x comma y is equal to true comma true. Still green. Logical disjunction. Only one case where it returns false. Return x, y is not equal to false, false. Still green. Logical equality has two cases where it returns false. I think I can do this in one shot based on what I learned from exclusive disjunction. Return x, y is not equal to true, false, and x, y is not equal to false, true. Still green? Yes. Remove the other if statements. Only one case returns false in logical NAND, so return x, y is not equal to true, true. Still green. There's only one case that returns true in logical NOR. That would be return x, y is equal to false, false. Still green. Material implication. Return x, y is not equal to true, false. The test is still green. Only one case returns true in material non-implication. Return x, y is equal to true, false. The test is still green. Negate first has two cases where x is true, so I will do if x is equal to true, return false. The terminal shows green. I will remove the other if statement. This means I could do return x is not equal to true. Still green. I'll do the same thing with negate second. Y is true in both of these cases, so return y is not equal to true. Still green. Project first, project second, and tautology are already pretty simple. I can change the negate second sum and do return not y is equal to true. Still green. I'll remove the other line. Now, in the case where not y is true, this would be a duplication. I'll, in essence, have return true is equal to true. So I'm going to remove the right side of this statement. Do the same thing with negate first. Return not x. Still green. Okay, I'll try this with material non-implication. Return x is true and y is false, so not y. Still green. I'll try it again with material implication. Return x is not true, not x, and y is not false, y. The terminal shows assertion error. False is not true. I'll change the and to or. And the test passes. Next time I see not equal in this test, I'll use or. Remove the other line. Logical NOR. Return not x and not y. Still green. Not happens twice on this line. I'm going to rewrite it in terms of not. Return not x, not or, not y. The terminal shows syntax error, invalid syntax. I'll comment the line out. And now I can write the factor in which would be return not parentheses x or y. The test is still green. I'll remove the other statements. Logical NAND, return not x or not y. Still green. And that would be return not x, not and, not y. Syntax error, invalid syntax. Comment the line out and get return not parentheses x and y. Still green. I'll remove the other statements. Logical equality, return parentheses not x or y and parentheses x or not y. The test is still green. Logical disjunction, return x or y. Still green. Logical conjunction, return x and y. Still green. Exclusive disjunction, return parentheses not x or not y and parentheses x or y. The test is still green. I can factor this out to return not parentheses x and y and parentheses x or y. Still green. Converse non-implication, return not x and y. Still green. Converse implication, return x or not y. Remove the other line. There you have it. Logical false always returns false. Logical true always returns true. These two are nullary operations. They do not take input. Logical identity and logical negation are unary operations. They take one input. I named that input x. Logical identity returns its input. Logical negation returns not its input. Contradiction all the way to tautology are binary operations. They take two inputs. I named the second input y and the first input x. Contradiction always returns false. Converse implication returns x or not y. Converse non-implication returns not x and y. Exclusive disjunction returns not parentheses x and y and parentheses x or y. Logical conjunction returns x and y. Logical disjunction returns x or y. Logical equality returns parentheses not x or y and parentheses x or not y. Logical NAND returns not parentheses x and y. Logical NOR returns not parentheses x or y. Material implication returns not x or y. Material non-implication returns x and not y. Negate first always returns not x. Negate second always returns not y. Project first always returns x. Project second always returns y. Tautology always returns true. You made it to the end of the truth table series. Would you like to test lists? I'll see you in the next one.